In this lesson, we're going to take a look at quadratic equations and functions. We'll solve quadratic equations using the quadratic formula. We'll identify x-intercepts of parabolas, and we will graph parabolas. And we will, of course, define what we mean by a parabola along the way. So here we see the quadratic formula presented, and it gives us a way to solve quadratic equations that are in standard form, meaning that we have a 0 on one side of our equal sign and everything else on the other side. When we arrange it this way, the a is the number part attached to the x squared, the b is the number part attached to the x, and the c is our constant term. We need to identify those three values and then plug them into this formula, and that gives us the solutions of the equation. We notice we have an x equals, so these are the solutions of the equation. Now here it's just being presented, and we're going to focus on using it. But if you want to see where it comes from, you can watch that video on Canvas. So what's nice and beneficial about this formula compared to, let's say, the factoring method is that we can always use the quadratic formula for any quadratic equation, whereas not everything can be factored. So let's go ahead and start with this equation below, x squared minus 4x plus 1 equals 0. And we'll start by solving this using the quadratic formula. So first we want to make sure that we have a 0 on one side, which we do. And next we want to just identify a, b, and c so that we can plug them into the appropriate places in the formula. So in this case, in front of the x squared, we have that understood 1. So a is 1. And the number part attached to the x is negative 4. We need to be careful and include that negative along with the number part there. And then our constant term is 1, so c is 1. So right away in the formula, we have a negative b. So since b is negative 4, negative b, or the opposite of b, would be positive 4. So we can write that out and say negative, negative 4. Or you can potentially skip that step and just go with positive 4. Plus or minus, that's how we're going to get our two different solutions here. B squared, so I need to square negative 4, so be careful with that part. And we'll talk about that shortly. Minus 4 times 1 times 1. And then all of that is over 2 times 1. So then we'll just start to simplify, beginning with mainly what's inside that square root there. Now we'll go ahead and simplify in front here as well. This negative, negative 4, it's positive 4. And then inside the square root, when we square negative 4, it's positive 16. 4 times 1 times 1 is 4. So just be careful in that front part of that square root that we're squaring negative 4. And so we know that when we square anything, we're going to get a positive answer. And so we got to be real careful if we're using our calculator, especially if we're inputting this entire expression, that we make sure and include parentheses around that. Or what I actually would suggest, especially in the case of a kind of a small number like this, just go ahead and square that. You probably know what 4 squared is. It's 16. So even if you're going to do the rest of this computation in the calculator, just put a 16 in there on your own, minus 4 times 1 times 1. Okay, then on the bottom we have 2 times 1, that's 2. So continuing in my square root there, that's 16 minus 4 is 12. And then we just look to simplify the square root. We know that square root of 12 does not work out exactly as a whole number. 12 is not a perfect square, but we can simplify it. There's a perfect square factor of 12, namely 4. So 12 is 4 times 3, and that square root of 4 is 2 times the square root of 3, then is how that simplifies. So I have a 4 plus or minus 2 square root of 3 over 2. And then I can factor out a 2 on the top. Both of my terms up top have a factor of 2. And then that's going to allow me to cancel with that 2 that's on the bottom there, and I just get 2 plus or minus the square root of 3. And so my two distinct solutions would be x equals 2 plus square root of 3. And I'm going to go ahead and get a decimal approximation for that one, even though generally I would say, you know, we are looking for exact answers. This is about 3.73 if we plug this in our calculator. And then our second solution there is x equals 2 minus the square root of 3. And again, a decimal approximation here gives us about 0.27. Okay, so that's how we can solve a quadratic equation using the quadratic formula. It gives us those two solutions. But let's try to head toward what the significance of those solutions is, or at least what one significant interpretation is. And so we'll start by graphing this equation or this function that we get when we just replace that 0 with a y. And we'll do that just by making a table of values here. And so I'll go ahead and do the first one to give you an idea of what we're doing here. And so when x is -1, we want to go through and plug a -1 in for x. So go through and replace x with -1. So we get y equals -1 squared minus 4 times -1 plus 1. And then just go through and evaluate that. -1 squared is 1. 4 times -1 is -4. Minus that, so plus 4 plus 1 gives us 6. And go through and do the same thing with a 0. 0 minus 0 plus 1, that's going to give us 1. And then I'll ask you to go ahead and complete the table on your own. So take a moment and pause the video and work on that, and then unpause and check your answers. Okay, now we see that table completed. And so if you go ahead and check what you got and make sure it matches up, then we're going to go ahead and plot these points on the graph and see what type of shape emerges here. And so if I look and see what I have, I get this kind of U-shape graph. I'll go ahead and sketch in. And let's go ahead and verify our work there using technology. And this is the Desmos graph of that equation, which looks a lot like what we came up with. Okay, so keeping this graph in mind, let's answer a couple of questions here. First, let's describe the shape of the graph. So we kind of talked about that as we were sketching it in. That graph has a U shape. And so it turns out that the graph of any quadratic function, so not just this particular one, but anything where that highest power on x is 2, and we have a polynomial, the graph of any of those is shaped like a U, and that graph is called a parabola. So that U-shaped graph is what we mean when we say parabola. And we'll flip back and look at it again to answer the next one. This question is, where does it look like the graph crosses the x-axis? And so if we flip back and look at our picture, we know that we aren't necessarily completely accurate here, but I think it's safe to say that on this left side, we're crossing the x-axis somewhere between 0 and 1. And then on the right side of the U-shape, somewhere between 3 and 4. So let's say between 0 and 1, and between 3 and 4. And then compare these approximate x-intercepts. So we're just approximating here, saying between 0 and 1, between 3 and 4. We can get a little more specific. It looked like it was closer to 0 than it was to 1, and it looked like it was closer to 4 than it was to 3. So those are some approximate x-intercepts. Let's go back and look at the solutions we obtained earlier when we solved that associated equation using the quadratic formula. So let me flip back to that solution here. because this used the same equation and just replaced that y with a 0. Our two solutions were about 3.73 and about 0.27. This is why I wanted to approximate them. So that's somewhere between 3 and 4, closer to 4, and somewhere between 0 and 1, closer to 0. And so the x-intercepts of the graph of y equals ax squared plus bx plus c generally are the real solutions of the equation ax squared plus bx plus c equals 0. So we started off by solving that equation first, and then we turned around and graph it, and we're noticing that our x-intercepts of the graph corresponding to the solutions of that equation. Now again, this hopefully isn't too surprising because we see the only difference between this equation or function here and the equation below is that here we have a y, and in that same place, essentially here on the bottom one, we have a 0. And we might remember from the past that whenever we replace the y with 0, that's how we find x-intercepts. Oh, please continue on in this module to view the videos for the rest of the examples.